So welcome everybody to the Introduction to Advanced Database Articulation with command line driven flux capacitation. My name is Lokui. I'm the PMD of CPE for MCB of the E&D division.
So there we have it. We can see that just by a few simple clicks within Visual Studio and the CE development tools, we've very easily configured and built an operating system image that's just going to run and prove everything that we've been looking at for the last 90 minutes. So let's go in and build the sub-project that we've just created, and this of course will finalize the build on the operating system image. And this of course will just take a few seconds to complete. And there we have it, that's done. The build is complete. Build's failed. This should be really easy. Not sure why that's failed. It doesn't matter why it's failed. This should be working just fine. What I can do is just run the operating system image that I built earlier, and that will just work, right? So just bear with me.
We talked about the new operating system that we're rolling out today, and you can see how we've brought new features like content enablement, network enablement, device enablement to that. And to show you how we're going to bring it all together, I'm just going to demonstrate one of the tools that we use internally to build this operating system.
I'm just going to do a target attach, and then we'll start the emulator, and that will work. So I haven't got that built either. Okay, well this will be fine. What I need to do, maybe if I build the application again.
Let's start off the mission statement. Now, let's talk about the top three things that we need to worry about when you talk about flux capacity.
No, I'll rebuild the application. That should do it. This will take a little bit longer, but when this builds, everything will be fine. Okay, well, that's broken again. Not sure what to say here. Give me a second. I'm just going to find the code that's broken. It's only one error, so this really shouldn't take very long to fix.
I'm Rob Tiffany. I want to talk to you a little bit about merge replication and how we can scale out to literally billions. Probably almost every citizen of the planet Earth right now with their mobile devices going back to the database. Notice here we're scaling out to multiple servers here. We've got gigabit Ethernet. We've got lots of hard drives. What I found is when you just throw more hardware at stuff, it gets even faster. So check this out. Look at that. It's kind of like you tell two friends, and so on and so on. More hard drives, more servers, more clients. You just keep doing it. Look, you push it again. There you go. Kapowza. More stuff. Now, if you want to do something with a little finesse, maybe put in some code and show your friends that no, I don't just throw hardware to make things faster and more scalable. This kind of code will take you to this level right here. How about them apples?
I think it's this application. I don't think it's the operating system. Just give me a second.
So in the last few slides, we've really given you an overview of a lot of the new directions that we're taking. And the more that we think about it, we've had team meetings lately, we find that developers would actually ultimately benefit just from knowing where we're going. So that's why today, for the very first time, without any knowledge to the PR department or to marketing or anyone else that's within the division, I'm single-handedly going to announce Windows Mobile 2009.
It's a C++ error.
So I'm really pleased to be here today to show you some of the new things we've built into the operating system for new services. And I'm really excited to see so many people here to talk about it, for me to talk to about it today. And one of the things I like about what I do is I get to play with great technology. And I really like that.
What have we got for this session? Oh, we've got a few minutes. There we are. Error. Line 688. 612. No, I'm going the wrong way. 7. Where was it? Where was the error?
Do you remember the time you knew the girl from Mars? I don't know if you knew that, or we'd stay up late playing cards and we went to miss cigars. And she never told me her name. I still love you, the girl from Mars. Sitting in a dreamy daze by the water's edge on a cool summer. Fireflies and the stars in the sky, gentle glowing light from your cigarette. The breeze blowing softly on my face reminds me of something else. Something in my memory's been replaced. Suddenly comes right back as I look into the stars. Do you remember the time you knew the girl from Mars? I don't know if you knew that. Oh, we'd stay up late playing cards and we went to cigars, but she never told me her name. I still love you, the girl from Mars.
Hey, did you get my email?
Yeah, I'm looking at it right now.
Electricity in the air, twisting all through the night on the terrace. Now that summer's here, I know that you're almost in love with me. I can see it in your eyes, strange light shimmering over the sea tonight, and it almost blows my mind as I look into the stars. Do you remember the time you knew the girl from Mars? I don't know if you knew that. Oh, we'd stay up late playing cards and we went to cigars, but she never told me her name. I still love you, the girl from Mars. Did I sleep in the chair by the window? It felt as if you'd returned. I thought you were standing over me. When I woke, there was no one. I still love you, the girl from Mars. Do you remember the time you knew the girl from Mars? I don't know if you knew that. Oh, we'd stay up late playing cards and we went to cigars, and she never told me her name. Do you remember the time you knew the girl from Mars? I don't know if you knew that. Oh, we'd stay up late playing cards and we went to cigars, and I still dream of you. I still love you, the girl from Mars.
A mobile OS you never got to see, you know? Did you notice anything familiar in there, though? When it talked about pivot. So we created the pivot widget a long time ago, like old school time. If you look at your, I know everyone has a Windows Phone 8 device, I'm sure. When you go in your email and you notice this pivot action that's used throughout Windows Phone 8 and 7.5, you'll see that that's the lineage. It came from the research we did a long time ago when we were trying to build Windows Mobile 7. Anyway, so that was a sneak peek at something that never happened. So I don't know what that means. Anyway, thanks for coming. I'm Rob Tiffany, and this is clearly the best session of the whole event because you're going to get to build some big stuff here based on this. Everybody go to the keynote? I like that. There was some cool stuff. I'd watched the streaming last night from Build in San Francisco, and so it was a lot of similarities, but definitely going deeper on IT Pro issues here with security, device management. I love John up there on stage trying to fumble around talking about supporting OMA DM. I remember doing OMA DM like a decade ago to do device management with Pocket PCs and our original smartphones, so it's kind of funny. It's kind of back to the future for me. So this session, I have like 10,000 moving parts on my laptop, 3 instances of Visual Studio, a bunch of copies of Access, SQL Server. It's going to be crazy. So I do mobile strategy stuff at Microsoft.
I've been there for the whole long ride with our mobile deal, as you can tell by the video there, going back to the CE and Pocket PC days and Windows Mobile 5 and 6, and then rebooting the whole platform and going to 7 and 7.5 and rebooting it again with 8. If you've come to any of our crazy sessions that we've had over at the booth, you know, kind of the genesis of what led to 8. You saw some of the UI things, clues in the old versions of Windows Mobile 7 that tried to be, and then at the same time talking about the skunkworks projects that we did in R&D to try to get the NT kernel and the core CLR to run on ARM processors, which led to us having Windows Phone 8 and Windows RT today. If you want to learn more about developing, how many developers do we have in here? Wow, look at that. That's awesome. You're going to make me do the Balmer thing, aren't you? Anyway, if you want to learn anything about Phone 8 development, Andy Wigley and I, he's here doing a bunch of sessions. At the bottom, we did this Windows Phone 8 Jumpstart on Channel 9. So there's 20 hours of videos that we did, you know, just 1-hour segments talking about different topics around Phone 8 development. So it's a good way to get started. I just released a book on tablets just to show you that I'm not just a phone guy. So there's some crazy stuff on here. It actually shows you how to do something ridiculous, like build a desktop app that runs on the desktop side of Windows 8, but it looks like a Metro app. It's full screen. It has Metro UI and everything. Because I know a lot of you in your enterprises still need to support technologies, older technologies, different things, and this totally integrates with a lot of existing stuff. So if anyone's interested, I'll have a question that I'll ask you at the end of the session, and you can raise your hand, and maybe you'll get it. You never know. All right. So I'm going to first start off with just kind of go with some general mobile concepts really quickly. A lot of them you'll already know. Some you may not. And then I'm going to tell you how to build some mobile middleware with things you might already have at your company, like SQL Server and IIS. Did you notice this morning in the keynote, the vice president from SAP talking about mobile middleware? He's talking about their product. You know, they made an acquisition a couple years ago from Sybase, and so they have Sybase Unwired Platform and Cyclo. There is a whole world out there of these new mobile middleware and development tools for mobile devices that are trying to get data from any back-end system out to any device, and it's called MEAP, Mobile Enterprise Application Platform. That's what this session's about. And so I'm going to just show you how you can take Microsoft technologies and connect those Lego blocks together to build your own MEAP. So that's kind of the gist of the session. I'll show you how to publish it out to the internet. So if you're doing it on premise in your data center and you need to get that data out to devices securely, I'll show you how to do that. And then I'll show you how to consume that data from all these back-end systems, both on Windows Phone 8 and on a Windows 8 tablet. And I'll kind of illustrate the code reuse. I'm using identical code on the tablet and the phone to do that. And then just a little blurb here. You know, I mean, maybe lots of people have written apps in here for our phone or different platforms. When you get into the enterprise, you may find that you're spending a lot more time on your back-end systems than you do on the device itself, because that's where all the complexity is, and also issues around scale. And so the gist of this, and again, this mobile enterprise application platform thing, this is a Gartner Magic Quadrant thing. Everybody knows what Gartner, they write those reports. CIOs buy those reports. Anyway, real quickly, you know, unlock the value of your back-end systems, get that data out to mobile employees, right? Any system to any device. That's what we're trying to do here. So while I'm going to talk to you about doing that and consuming that from Windows Phone 8, and Windows 8 tablets, what I'm also going to show you will work with any device, actually. And if you've been to any of our sessions, you've probably seen this slide. Yes, we're built for business. So kind of in my talks I've been doing like 1,000 times now at the booth, obviously we have the same NT kernel and OS running everywhere on all kinds of different platforms. You've got the same Office and Link and SkyDrive running on tablets and phones and everything. We've got a great solution for mobile apps, which we're going to talk about today. And then this unified management system with System Center and Intune in the cloud to manage all your PCs, laptops, devices, as well as other devices, iOS and Android as well. So we've definitely got a great collection of solutions to help you these days. So let's talk about some enterprise concepts. Why are companies going mobile? So here's the kind of the first obvious one that everybody probably thinks of. I can work anywhere, anytime. I can go to the coffee shop and work. I can work from home. I can do whatever. How many people have a flexible kind of work style where they work? Do you get to do things, Okay, there's some. That's good. So the rest of you are chained to your desk, with an Ethernet cable. All right, I gotcha. So anyway, just being able to work from anywhere, anytime. Now here's another nuanced one, though, and this might be a little harder to understand. Real-time versus batch mode, having to do with decision making. Here's what I mean by that. If you live in a world where the only computing you do is when you're chained to your desk with a big Ethernet cable going in the back, but you have to do some work in the field, and you're out there working with customers, and maybe you have to capture some data and stuff like that. I saw a session yesterday. I don't know. The idea, here it is. I checked my calendar, my watch. It's the 21st century, and yet I still see people out in the field working out with customers and capturing data with pen and paper. And maybe sometimes they're not. Maybe they're entering on a computer. And then I see them, after working outside all day, capturing all this information, they go back to the office at 1700 at the end of the day. And what do? They sit down, and then they bring up their computer, and maybe it's a SAP console or whatever, and then they start transcribing that data into it at the end of their day instead of going home from work. I came up with a really nerdy kind of term for that, kind of out of the database world. You know what ETL is. So I called it human ETL, human extract, transform, and load. Yeah. Woo! All right. So timely information. So there's the part about capturing data, getting it back, and creating a real-time enterprise, but obviously pushing data out to devices through various you got to have wireless devices and sync technology. So that at that point of activity, where things happen, not later, not too late, not back at the office, but right then, have what they need to make better decisions with customers and partners. And then, as I said earlier, so right now in the Gartner list of the most important top 10 things for chief information officers around the world, mobile is number 2. And then inside that, one of the top things is CIOs want to extend their back-end systems out to mobile devices. And so this is exactly what I'm going to show you how to do. And then last but not least, let's not forget about analytics, that data captured in. Everybody the last year, we've been talking about one thing, right? Big data and Hadoop, and all I ever hear about is big data, big data. Well, remember where big data comes from. It comes from a lot of little data. And that little data is sensors and mobile devices and things like this. And so that flow of data coming out from the devices and into your databases and your business intelligence systems to mine that data and do analytics is critical. So how do you make this happen? So you've got this mobile middleware, which I'm going to show you how to build, to integrate all these mobile data sources, back-end systems, packages, databases, everything. And it sits in front of that, and it's a facade, a server facade in front of that, so that there's only one view that the field has to look at, the devices have to look at. And it pulls data in from different places and combines them together, then exposes them with web services in a format that any device can consume. Not a proprietary binary protocol, but something that works with any device, because you don't want to create your own blockers to mobile devices by using a proprietary wire protocol. The way you publish it out, and I'll dive into this just a little bit, is this idea of a multi-channel access gateway. What in the world is that? Multi-channel means it works with lots of different protocols, and it will work with any kind of device, is all that means. And this gateway. So think of it as something like ISA server or UAG, some kind of edge appliance or server that securely publishes data out from your data center. Then the other thing is the development tools to write the code to make some of this happen. Obviously you're building the mobile app and the user interface and the logic, but you're also building the back-end integration as well and the back-end logic. Being able to use one tool for that is a big important thing. And then last but not least, the devices themselves, the apps. And whether it's a native app or a web app, both of them should be able to consume that data that you're coming from the back-end systems equally, do offline transactions and send it back. So here's kind of a visual representation of the text that I was kind of talking about there. And so if you think about from top to bottom, your mobile middleware here, you know, IIS, SQL Server, that kind of thing. And so that EAI, the integration to back-end systems like SAP or Dynamics or something, and to databases, Oracle, other SQL servers, you know, Teradata, whatever, DB2, and then publishing it out through a gateway, you know, wrapped in SSL to any device. That's kind of the vision. That's what we're shooting for here. Because it's a mobile world. Mobile's taken over the whole world. Everything, that's the biggest thing going. It's the biggest mega trend in technology. And so while I want you to use Windows 8 and Windows Phone 8, I also recognize that we live in this BYOD consumerization of IT world, and employees are walking in the door with every kind of device. So I want you to be able to empower those people while still using your back-end Microsoft technologies. So let's talk about building that mobile middleware. So I mentioned the whole EAI integration with back-end systems and data sources, and then aggregating data together from those systems and caching it, rather than having to hit those back-end systems directly. A lot of those back-end systems are not designed to be pounded on by thousands of devices. And so you're going to help them and pull that data in a controlled fashion out to a system that can handle the load. Then you're going to create business entities, like a mobile business object, you know, that models that looks like the data that's coming from those tables that will go out to the devices. And then you're going to use RESTful web services to expose those business objects out to devices. And if you've heard me on my soapbox before, you know, why REST versus SOAP? It's lighter weight. You know, why JSON versus XML? It's smaller. Things like that. Because remember, we're going over wireless data networks, and things can get pretty slow. So let's dig into this a little bit. So when you're looking at different MEP packages from different vendors, one of the most important characteristics or things you're looking for when you're trying to find one that you like is how many adapters does it have to talk to back-end systems? That's one of the critical things, because you don't want to, there's lots of MEP packages out there that only support maybe half a dozen different back-end systems, which is not very helpful. So all I'm going to show you here is this is just a quick look of a lot of the kinds of things that SQL Server integration services, the SSIS adapters, can talk to, because this is a critical part. The adapter is a big deal, because remember, the vision, any back-end system to any device. So if this isn't good, and it's only one or two back-end systems to any device, you really haven't done a good service to all the employees or your customer. And so look at, I mean, all these packages, databases. Obviously, we can talk to any database, as you might imagine. Messaging, TIBCO, WebSphere, Internet. If I need to, these adapters could call web services. It could, if you have data like in Salesforce.com or whatever, and you just need to aggregate this stuff together. So it's a great Swiss Army knife that can talk to anything. But it's more than that, because the other part is that you don't want to have to write special code for all these different things. You need to be able to have it be easy and visual and done one way for everything, because that's part of the whole reason Gartner has these magic quadrants is efficiency and to save money and to bring value to the company. And so you need to be able to use something that you train people on one way to do things, and then no matter what they're talking to, it works exactly the same way, rather than it being 30 different ways or 40 different ways. So when I talk about, and I'll show you, I'm going to have lots of demos here, visually connecting those adapters. So I told you one of the critical things is being able to just use one tool, development environment to do everything, not 20 different tools. So Visual Studio includes this SQL Server data tools that are built into it. And so it allows you to visually create these SSIS, SQL Server Integration Services packages. And so what the example I'm going to give you today is I'm just going to go, to make it simple, because I have so many things running on my laptop right now, I didn't have room left to install SAP on my laptop, so I'll have to fake it out with Access, so please forgive me. But anyway, I'm just going to give you a quick example of going from a data source to a destination, and you can see how visual it is, and it's illustrating something on a small laptop, but it's illustrative of something much larger. It could be with any system. The other critical thing around MEP is because there's a whole list, a checklist of things. They're called critical capabilities that Gartner talks about. One of them is security to every tier of the system. Data at rest on the device, data in transit going over the internet, data when it's in the database in the middleware, data when it's moving through these back-end adapters. It needs to be secure everywhere. I don't have to remind you, the security problems we're having these days. People are getting hacked all the time. And so you don't want to be leaving the door open for that when we have all the capabilities to lock that down. And the last thing I'll just mention is, in case you're wondering if SSIS is a good way to do that, we hold the world record for the fastest ETL operations. So it is a good solution. It's a fast solution. It's an easy solution, because obviously part of that user experience, when someone hits a button on their device and it goes out and tries to request data, everything needs to be as fast as possible and as scalable as possible. And so SSIS is a good choice for that, since it holds the world record. So here's a visual representation of what we've talked about so far. As I go through the session, I'm going to slowly build out this picture inside a private cloud. But this could be in your data center. You probably noticed, about a month ago, we launched with Azure. We now have infrastructure services available. And so now you can upload your own VMs, or you can use the gallery to create virtual machines of Windows servers and SQL servers and things like that, and AD yourself. And so this could be that place as well. So basically all I'm showing here is SQL servers where we're going to aggregate data together. We're going to use the SSIS adapters to connect to all these types of back-end systems to pull them down. So that's the visual representation. So now let's look at the real thing. So let me switch over here. It's my laptop. So, as I mentioned, the first thing I'm going to show you is 3 Access databases. So like I said, I've got so many things running on my laptop, I couldn't really put SAP or Dynamics or something on there. So what I'm going to do is I'm going to illustrate the concept, I'm going to use 3 instances of Access, 3 different copies. One's going to be pretending to be a CRM system. Another one's going to be an ERP system. And then the last one will pretend to be a mainframe. And so basically what we're going to do here for this example is I have this one Access database here, the CRM, and it's just a list of customers that we're going to pull. So I'm going to pull that, but it could have been any system. Then the ERP system, I'm going to pull just a simple list of products together. And then last but not least, we'll have a mainframe here. It's empty. This is where orders are going to go to. And so this will be empty now, but at the end of the demo, it'll be full with data. It's not enough for me to because anybody can get up here and show you a demo of SQL Server with data in it and syncing it back and forth. The whole meat vision is it's got to go to back-end systems and out, and then all the way back in again, round trip. So there's the data you can see there. Now let's look into SQL Server, since this is going to be the heart of our middleware. So I built 3 tables there on the left-hand side that mirror the 3 databases. And first, I need to prove to you that there's no data in them. And there should be no data in orders, because we haven't placed orders yet. So just did queries on that. So now I'm going to go into our adapters, our SQL Server data tools. This is part of Visual Studio. So I'm not kidding when I'm talking to you. This is a drag-and-drop visual environment to connect back-end systems into SQL Server to do that. So here I have 3 data flow tasks. One is for products, one's for customers. Those are coming from those back-end systems to SQL. And then the last one, orders, is going to be going outbound. And then if you drill into one of these, you can kind of see how it works here. So I have a CRM OLADB source, and so that's the customer table in that Access database, and there's the columns that I'm pulling from. And then the destination is SQL Server, and so it's going to connect there, and then you see the mappings, the one-to-one mappings from the table. What's great about this is it's a full ETL product. So sometimes your back-end systems don't match up perfectly with SQL Server data types and things like that, and you may need to do transformations. Luckily, we can do that. And so in this case, I'm just going to do one-to-one matches, but we could transform it. And again, everything runs in RAM on this and is incredibly fast. So the next thing you do is just run it real quick. So I'm just going to hit play here. And you'll see the little green checkboxes that let you know that that process worked. Let's take a look at the orders won't do anything. And then there's your products. And then, it's hard to see here looking at the bottom, but you can see the debug code showing what it's doing as it's moving the data across. So we're done with that. Now I want to go into SQL, and let's refresh that. And sure enough, there's our list of products. Still no orders, because there shouldn't be, because the orders are going from a different direction. And then when I refresh the customers, you see that. Now, of course, the other thing you'll probably notice that you're probably wondering about, and I'm going to go in the next section, is what are those GUIDs doing there? This has to do, these are added because I'm going to show you in the next section here how to scale out the SQL Server to do high scale stuff. All right, so step one is complete. Back-end systems to middleware. So let's move along. So scaling out SQL Server. This isn't necessarily a requirement for MEEP, but what is important to me, did anybody hear my MEEP talk at the booth yesterday afternoon? A couple people? So I hate to repeat myself. But anyway, so it's so important. So I spend a lot of time, I fly around the globe helping customers with mobile problems. And I have found personally that I spend 80% of the time on the server for some reason when I'm going to fix somebody's mobile problem. And I'm like, why is that? Well, the reason is scalability and performance 9 times out of 10. Someone has built a system for their mobile devices. They got it to work for one device, 100, 1,000. But then when they got to 5,000 or 10,000 or 100,000, the system could not handle the load. And it was slowing down, and it couldn't scale, and it wasn't meeting their requirements anymore. So I'm a student of scalability. I study it. I watch videos from architects at eBay and Facebook and Google to figure out what are they doing, And so, like I mentioned yesterday at the booth, what does Facebook do to be able to support 1 billion users? I mean, you got to figure if I can follow what they're doing in my own system, I'll probably be in good shape. And does Microsoft have the technology that allows me to do what Facebook is doing? So let me just quickly go through Facebook really quick. Started out in a dorm room doing PHP and running on Linux boxes and Apache for the web server and MySQL. So the LAMP stack, very common. I don't have any money. I got to build something. And then it gets better. And then one day, I'm popular. Lots of people are using this system. How am I going to handle the load as it increases? So what they did is, so a lot of people will start out, they'll have their one web server and their one database, and then as it gets more popular, they may load balance additional web servers, but they're still going against a single database. And then maybe they'll cluster the database or things like that. But at some point, no matter what server you have, even if you're on a mainframe with the most powerful system possible, you will saturate that database, no matter if it's SQL Server or Oracle or DB2 or Teradata. It doesn't matter. Every database has its breaking point. So how do you get past that breaking point? Well, you have to create a horizontally partitioned shared nothing architecture with your databases. You need to scale out your databases. You need to break them apart into shards to scale out, because I can't have 1 billion devices all hitting one database at a time. So what does Facebook do? So they're using MySQL, and MySQL had replication built into it. And so they could do this read-only, download-only type replication to other nodes. Well, you can do that with SQL Server too. We have built-in merge replication. It's a very mature product we've had in the system since 1995, and we keep enhancing it. I've used it for years to synchronize devices. But you can use it to scale out your SQL servers and to create shards and different nodes. And so the takeaway here is when you walk through SQL Server, if you need to break things apart, you have to get in the mindset, possibly, that you may have to break apart things like referential integrity and have all those different databases, tables, be able to stand alone on their own. And so maybe step one is I'm going to do complete copies of my database over and over again to different nodes. and have people hit that. And that'll take you so far. But then when you run out of room there, then you'll start breaking those apart. And you need to go table by table and have each table on its own server. And so replication allows you to do that. I mean, literally, it's a wizard that goes through and you choose database, check this, check all the tables I want, check the columns. I mean, it's very simple, to walk through this wizard. And so you can shard out there and have different tables on different nodes. And so they're all going to be smaller. If that's not enough, we have filtering tools built into merge replication in case you need to break it apart even further because you're really popular. Now we're getting out to millions of devices. And so if you need to break that customer table into separate pieces, you can use the filtering built into merge replication to do that. And again, it's really simple to do so that you can break your customer table into different sections and across different servers based on maybe the first letter of their last name, things like that. The other note thing here is that most of them are going to be read-only replication. So it's going to be download-only from the main SQL server at the top of the pyramid, and a bunch of them are going to just be read-only, download-only. And the reason for that is more people select data, get data, than they post or send new data. Most people are reading. So maybe 80%, maybe 90% are just viewing data, and then a smaller are doing writes. And so that's how you're going to model your system. But then I know you're like, okay, great, Rob, we've built the most scalable database architecture in our data center, but I need to have failover. Well, I'm going to do you one better because we have lots of great failover tools built into SQL Server like Always On and things like that and clustering. But if you want to do geo-replication, things like you think of when you're thinking of Azure and stuff like that, you can use the peer-to-peer transactional replication built into SQL Server to do exactly that. So you could have a second or a third data center that has at the top of the pyramid other SQL servers that are using peer-to-peer replication. And then beneath each of those data centers, they have their hierarchy of scaled out databases. And so you can absolutely do that. And then guess what? It's not just data, it's not just a DR site. It can be active-active. So you can have devices hitting multiple data centers, and the database synchronization will keep up with the changes for you. So here's what that looks like. Here's the visual representation of that. So I'll get rid of things at the top as we kind of move our way down so I don't clog up the picture there. So now you've got SQL Server. It's got that data, that CRM data, the product data here, and it's going to use replication to pull it out to these SQL Server subscribers. We use terms like publication and subscriber and things like that, but that's all it means. And so these over here will all get different sharded copies of the data. And then, of course, this represents a separate data center here where you're using peer-to-peer to do geo-replication. Of course, I have to make it real for you, right? So let's look at it. All right. So on the left-hand side, kind of in the Object Explorer, so you can see here we have Contoso Fruit. It's kind of our SQL Server at the top of that hierarchy, and with our 3 tables. So down here, though, you see I have customer node and order node, and I have product node. And in each one has just one table in it. So I have them all together on my laptop for this session, but in real life, you would deploy them on separate machines. So let's just take a look really quick and see if anything showed up in customer node. And look at that. So the read-only, download-only replication, when we did that first ETL operation into the top database, it synced it down to the bottom one. And now the answer to wonder why we have these GUIDs, the GUIDs are used for change tracking to keep things in sync as things change. It's not as important for download-only stuff, but for the order table it will be. So if I do a quick look at the order table, again, it should be empty. And then the products table on the products node, it's got its data. So now we've simulated here in one box the different shards in the scale-out system. Let's take a look here. If I go down to the bottom, and you see here, there's the replication folder down at the bottom, and you see I have 3 local publications. So I'll just take a look. We'll look at the properties of one of them. And so I create this customer publication. I click on articles. All an article means is like the tables, columns, and rows and things like that. And so here you see I've checked the customer table, and and the columns that are in that. And it's checked here as a download-only table, because most of those are just going to be read tables for scalability. Here's the part where you do filtering. I don't have any filtering for this one, but actually let me go to the order publication table, because I do have a special filter on that. So sometimes you've got, so here's a filter for orders. Let me show you the screen here. So we have this neat little just edit box to do these special filters. And this is where you would do where you filter, but you put in where clauses and things if you only want certain tables and things like that, or columns. In this one, though, this is a strange one. It's really simple, because basically when you bring up the box, it automatically says that in the filter statement on the right, it automatically says select blah, blah, blah from whatever that table is. I included where 1 equals 0. Well, that doesn't make any sense, because 1 will never equal 0, but that's exactly what I wanted to do. When I put that special filter in for that publication for orders, because remember, our orders are coming from the device and going up, right? So when you do that, the replication, it tells replication from the database at the top of the hierarchy to pull down an empty shell of the order table down to the order node shard, but don't put any data in it. And then it also tells it when data comes up and is sent up from web services from the device and lands in that order shard, once it gets it, it says, oh, yeah, here it is, and then I need to get rid of it, and I'm going to synchronize it up to the top database, and then I'm going to clear the bottom one out. So you're going to keep that one empty. So that's what that does for you. And so we can see now the data is out at the different shards, and so now we need to do something with it, right? We got to get web services to expose that out to the internet. So, important thing, there's lots of proprietary sync technologies, and I've used them all, and there's a lot of great ones. If you're tied into certain products, you know, it might be okay. But if you want to make sure that you're building something that can work with our devices from Microsoft, but your devices of the employees that you have too, you need to make sure you're using a multi-channel transport and data format, something that works with anything. So, REST is a lighter weight way to do web services than SOAP. And we have easy tools. I'm going to show you how we use our new web API to do that. And then JSON, you know, JavaScript object notation. It's just a simple way to serialize data from data that is in the database and to send it over the internet to the device. It's much, much smaller than using XML or some other data formats. And the reason we care, again, is because you might be on GPRS. And so if you can find a smaller way to send data, it'll be faster even over slow networks. And so it's all about good user experience, right? You want the users to be happy. And then you enable compression on the web server and on the device as well. Then I talked earlier about the business objects. So you see I have a couple of simple tables, and I'm keeping them simple on purpose just to make it for illustrating here. So you'll build these business objects like a customer object, you know, and a product object that models what that table looks like. Because we're going to put the data in the form of that object, and then it'll be turned into JSON automatically. You don't even have to worry about that. Our tooling does that for you. And it turns these collections of objects. So you think of a database table in columns and rows, and it automatically serializes that into collections of objects as JSON. And then we're still worried about performance and scalability. We've done great stuff on the database side, but there's some more we can do. Obviously, we need to scale out and load balance our IIS servers as far as we need to go, but we can do more too. We can use caching, because the fastest, best query against a database is the one you don't have to make. You want devices that are requesting data. If the data is in cache, in a whether it's on, so we have our .NET memory cache, which is on a server-by-server basis to cache things that are going out or in. And then we also have App Fabric caching. So let me take it back to the Facebook analogy. So Facebook, maybe they've got 30,000, Apache servers load balanced out there in front of their databases. And they're using Memcache to do distributed caching, because there is no way that web page for Facebook is going to come up fast when you and 1 billion of your best friends are all trying to go to the website. So caching is part of the secret sauce. And so distributed caching. So we have that with App Fabric. You connect it, and you can either do the caching at the web tier, or you can have a layer of caching servers. but the basic architectural pattern is device from the field is requesting data. It looks in the cache first. If the answer is there, it gets the answer instantaneously. Great user experience. If the answer is not there, then it goes through, queries the database, gets the answer, returns the answer to the device, and puts the answer in cache so that the next person coming along gets it from cache immediately. And then you put expiration around that because I know data gets stale after a while, and so you don't want to, depending on how frequently data changes. How many people went to the keynote where we talked about SQL Server 2014? Do you remember what they talked about? In-memory OLTP, stored procedures written, compiled to machine code. Cache makes a difference. And so when the database is all in RAM, you'll start to get the benefits that we have of a caching tier right at the database. Because obviously it's common sense. Not having to hit a disk is always faster if you can just get things out of RAM. Now, like I've been mentioning, we have to have security to every tier. So I showed you the security for the SSIS adapters. You can encrypt, SQL Server can encrypt all the data at rest in those staging tables. And then, of course, you want to use SSL and basic auth. Now, I know you're thinking, oh, there's a lot of better ways to do that. The reason I'm saying this in this case here, I'm thinking, I don't want to use the words lowest common denominator, but I need to make sure I'm working with something that works with every device. Every device supports basic authentication, for sure. And every device supports TLS, SSL. You can absolutely build on that if you want to use OAuth and do things like that, like we do in the cloud. But this is the one thing you know for sure is going to work. So now here's how our picture has evolved now. So now our IIS servers, they're not communicating with a database at the top of the hierarchy, and nobody's even talking directly to the backend systems. They're just talking to the sharded database nodes. And notice that these are all read-only because they're all going to be retrieved. And then these up here are going to be write only because this will be new data, orders coming from the devices to go up to that. And so they'll just hit that, and then of course you'll have the same thing over in your geo-replicated system in another data center. So let's take a look at that. So when we released Visual Studio 2012, we came up with, I don't know if you're familiar with ASP.NET MVC. So we have MVC4. And part of the Model View Controller MVC4 is this web API that makes it very simple to expose web services as REST and JSON. In the past, I've used WCF for that. And I think what happened is we've seen such a big trend in the internet that most giant internet sites and different internet properties, they're all exposing their APIs via REST and JSON now. And so we were seeing a high degree of people, WCF can do everything, but lots of people were using it for REST and JSON. So we thought, let's see if we can come up with a lightweight, easy way to do that that's even faster so you're more productive than you might have even been using WCF. So let's go take a look at that Visual Studio. So I got 3 instances of Visual Studio. So here I've got the web API instance. So remember I told you that we need to we need to have business objects, mobile business objects that model the table. So let's just look at one. This is just real simple stuff. You just I have a customer object, an order object, and a product. It's just really simple. There's no rocket science at all. It's just exposing 2 properties, an ID and a name in this case, which match up to the simple tables and column structure that we have. The next thing is the controller. The controller is where the magic happens, and probably ultimately the best way to describe this to you will just be to debug through this. Do I have your permission to hit F10 and F11 a whole bunch of times? Anyway, it's the best way to learn. I'm going to walk through the code, and I'm also going to show you how you don't even have to have your client app built yet to build this and test it. And you can have the whole middle tier tested and working before you've even built your mobile client for iOS or Windows Phone or anything. So we got our business object. And just to kind of give you an idea, I won't totally build it out, but see, we have these controllers, kind of part of the MVC paradigm. And so I have a controller for each one, a customer controller, an order controller, a product controller. if I wanted to create a new controller, which is the part that exposes the data, using RESTful things, get, put, delete, post, things like that, because that scales the best. Use what the internet's good at. So here I do add controller, and it just gives me a simple dialog. You put in the name of the controller that might match up to the objects that you're wanting to send out to the device, and then you have different templates. It could be empty, you can just have read-write actions, or it could work with the entity framework. In my case, I'm just querying the database directly instead of using an entity framework. And so if I scroll down here, the first one I'm going to use here is a get, and I'm going to get all the products. And then we'll step through the code. But you'll also see that are automatically created for you by the wizard is a get where you pass in a parameter to start filtering it, like this one here. Or here, a post, if you're posting data, or a put, or a delete. And I'll show you, you'll get to see that when we post an order up from the system. So let me just run this. And there we go. So you get this easy little template. So this is kind of your home base. And this is how you can start to test it. So if I go up here and type API-customers and hit enter, look at the very bottom. You'll see I've got an answer back here. And it's hard to read. I apologize. But the answer says it's a file. It's customers.json. And notice that it's only 323 bytes. And so I open it up, and so that's the JSON representation of the data you saw in the database. Customer ID, name, and so that's just that simple list. I've done sessions in the past where I showed about 5 or 6 different ways to send back the same data. In some cases, this data was, getting close to megabytes. It was a different set of data, but I could show how as you use different wire protocols, you got it smaller and smaller until we're sitting here talking about, 600 bytes instead of, larger data sets. And this is all critical because, again, it's about speed and performance and the user experience. Because you don't want to do all that hard work on the back end with SQL and caching and everything only to have all that work be for nothing because you're using some giant fat wire protocol the way you send your data. So that's kind of what it looks like there. And then if I do a different one, if I do API for products, is that what I... Now look at that. It hits the breakpoint in Visual Studio now. And so I'm just testing it from IE. And so I haven't even built anything on the client yet. And so you can see here, real simple, I've got a connection string because I need to talk to SQL Server in this case. And I'm going to return this get operation. I'm going to return, a list of product objects. So if I just start hitting F10, a lot of this will look really familiar if you've done ADO over the last decade. I'm just creating a command. I'm opening my connection. You see I have a very simple, just super simple select statement to pull that. I'm going to double check and ensure that I actually have rows, because if I don't, then I'll just quickly end the process and return a null and not waste time building out all these objects. So now as we move down, I have a product object here. And then I need a product list because I'm going to have a list of product objects coming from that table. Each row is an object, right? And so I'm going to initialize a generic list of type product, and then I'm just going to start iterating through. And remember, it's a simple system here. So I'm just pulling from product ID and name. And the interesting thing though is I'm going against the shard. In fact, let me show you the web config. Right here, normally you're used to just having one connection string talk to one database. Notice I have 3 different connection strings talking to 3 different databases because these are the different nodes that could be on different servers if you need them. And so this is just the real typical simple ADO.NET stuff. You can see if I highlight and do IntelliSense, you can see I'm getting those products. They're going into the product object. If I highlight the product list that's growing, you see it's already up to 2, and it's going to slowly fill with data. And so we've seen enough of that because it's just going to keep iterating. and then it's done. And again, you open it up, and there's your list of JSON products. And I didn't have to write any special code to turn it into JSON or anything. I just get it automatically. So we're feeling good here. This all works. And so I'm just going to leave IE running here, because I'm going to keep this in debug mode, and we'll move on to the next part of the session here. So our middleware is done. Pulled it into SQL, we've scaled out, we've got web services, we've scaled out that, we're caching, we're doing everything great. Now we need to get that data out of our data center and out into the internet where the devices can consume it. So we want to do that in a secure way. If you're doing it from the cloud, it just kind of works. But if you're coming out of your data center, you've got to use some appliances. So how many people here use Exchange Server at your company? Yeah, most of you. Okay. So the steps that you or your colleagues or someone did to make that Exchange Server get that Outlook web access so you can be at home or wherever and you see the web page to get your Outlook email, they took some steps to make that happen. What they did is they probably used ISA server or UAG or TMG, or maybe they used some other reverse proxy product to securely publish that Exchange data out to the internet. So it's something you've already done. And it's something you should be comfortable with. Well, you can use that same paradigm for business apps, for business data going out, or for websites too. So UAG, I'm just going to use this as an example. It could be ISA server or whatever. Imagine a server or an appliance, and it usually has 2 or 3 NIC connections, one that's pointing out towards the internet. Maybe you have the front firewall here, and this is sitting in the middle in the DMZ, and it's pointing out to the internet, and you got one going out to the back that's going to go through your back firewall. And of course, you secure that with a cert. And so it's listening on the external IP address. So your mobile devices are going to call into an IP address or a domain name that you're going to register, set up for them to find it. It'll be a special name, whatever the name of your company, whatever, com, or whatever it is you have. And it's going to listen to that and pull it from the outside. When a device is making a request from the outside, it's going to hit that. And then it's going to pass that request to one of the back-end web servers. Remember we have all the IIS servers, load balance? Well, it's probably just going to go against the virtual IP address from the network load balancer cluster. And so again, yeah, you'll specify a DNS name. And then the path. And ultimately, that path is just taking it from outside the internet in there and then proxying it right to a particular virtual directory in IIS where we have our REST ASP.NET website, web service hosted. You have the option, of course, we're a business, so we're wrapping everything in SSL like I talked about with basic auth. You can either terminate that SSL connection in the DMZ, or you can pass it on through back to the web servers themselves. You can pre-authenticate. You can do constrained delegation. You can pre-authenticate with AD out there in the DMZ, or you can wait till it hits the web server and authenticate, the people's credentials when they're synchronizing that way at that time. And so, things like ISA and UAG, they're more than just a reverse proxy. They're a security appliance. They accelerate things, and they also can do packet inspection. And so they can do deep packet inspection, look inside the packets to make sure that it's coming from a place that you want it to, and that there's no malware or you don't have someone spoofing you or something like that, because security is paramount. And this is the best part about it. You don't have to have a VPN. This is how most Microsoft server products are built and sold. Is we don't want you to require you to have a VPN. I know lots of you do, and I know some of you're required to make a VPN connection from your mobile, your laptop, or whatever before you hit back-end systems, but you don't have to. We're encrypting the tunnel just like you would do with a VPN, and we're using a secure reverse proxy to do that. And so instead of a VPN that brings the whole network out to the device, we just use this, and so we only allow the web services out, and not just to the device, but just to the app that's calling it. So it's in many ways more secure because the surface area, your attack surface area is dramatically smaller, and it can only be seen by the device, and you're inspecting the packets. It's also a better user experience, right? I mean, this whole time I'm talking about how to give the best user experience, speed, scalability. Well, the hassle factor goes away too. people, just like you're at home, you can browse the internet. You just use apps. You just want to use them. Well, when you do it this way, you just get to use the app, and it just works. You don't have to set up VPN connections. So here's where we are now. So now we're at the IIS level. We've got load balance IIS with virtual IP. And so UAG's reverse proxying out, devices are going to come through here and go out the back firewall. And it's publishing these discrete endpoints here of virtual directories to get out to the internet. So let's see it in action. All right. So let's take a look at, we'll have another instance of Visual Studio, and we'll look at Windows Phone, which is appropriate since this is a Windows Phone session. So I've got here in my main page, I'm just going to, I'm not building out a big advanced client here for you. All I'm showing you is the basic building blocks that you need to know, and then you'll build your business logic on there. You need to download data. You need to do transactions offline. I'm going to show you how to take data offline because you may not have connectivity, so you want to pre-fetch data, have it offline, be able to work with it, and then send it back later. And then obviously upload the orders. So I'm going to download the products, the customers. I'm going to create an order, and I'm going to upload it. And so we'll do that round trip. And I'm going to do it from Windows Phone in the emulator, and then I'm going to do it from the tablet. And I'll show you that it's identical code, too, which is another benefit. Less time. You got to market faster on 2 platforms, right? And lowered risk to your project. It's all good. So notice here, remember I showed you the customer object up on the server? So I have the same customer object here on the device because I'm going to cast that JSON stream when it comes in back to the customer object, to the products, things like that. If I kind of go here from the top to the bottom, so you won't do this in real life, but I just put all the code in this main page here to make it simple to understand. So at the very top here, you'll see I've created 3 different generic lists of type, product, order, and customer. Like those are our business objects coming from the server and instantiating them. And then I've got this HTTP base address that I'm calling, which I had to cut and paste in right now because I got a different IP address. That's the interesting thing. I don't know if you've worked with the emulator on Windows Phone 8, but it actually runs in Hyper-V, and it's really a separate machine. And so it can't just call localhost to get to your local IIS server. It has to know the IP address or the name of your laptop or whatever. And since it's always changing, like when I'm here, I had to paste it in. Now, the simulator for the tablet is different, and you can just do localhost to call that. So that's how we just get things set up. And because we're all a bunch of developer geeks in here, we know the best way to learn is by doing. So let's just fire this up. And there's our client. So we need to download these products and customers, and this is how you're going to learn about the code. So we hit the breakpoint and that click event for products. So I'm using the HTTP client. We've just released, I don't know if you know what portable class libraries are, but they're .NET libraries that can work across all of our different platforms. So we just recently RTM'd our HTTP client portable class library, and that's exactly what I'm using. And so I can use the same library on the phone as I am on the tablet, or I could use it on the server, actually. And so it makes it very simple to use the same code and do asynchronous calls to REST or other HTTP type things. So I instantiate that. I'm using, probably the other thing you see a lot now in the newest versions of .NET and WinRT is the idea of doing await and having, if you're using an await, because it's a different way of doing our asynchronous calls. Everything needs to be asynchronous. Again, why? Because the user experience. You don't want a frozen screen, right? And then you have to mark your method as async if you're using those type of calls. So my response object, I'm just going to get that. And look at that. I instantly switched to the server side. So now I'm in the server code that we went through before. So this should look familiar to you. So I'm not going to bore you with running it again. So I'll say continue. And now I've gotten the response back. And a feature of the HTTP client is you can do a quick check for a success code. so you don't waste your time. So my success code is true, so it means my payload of data came back successfully. And so now I need to do something with it. So I create a stream reader, and I'm going to read the content in from the response object. And then I'm going to use, since remember we're using JSON, so one of the things we have built in is a data contract JSON serializer, and I'm casting it to type of object, the product object that I showed you before, customers objects, the business object, and then that's how I'm going to convert that JSON into .NET objects that you can actually work with on your app. And so if I look here now, like we did on the server, if I highlight products here on the client, on the device, you'll see that in fact we successfully pulled all the products down. So this is good. This is working great, just like we want it to. So now I want to quickly show you one method of saving data offline. If you've been to the booth, I talked about a number of different methods, or if you went to my session a couple days ago, we have SQLite is a way you can, and Andy Wigley tomorrow morning is going to do a session on using SQLite. I know that's the world's most popular mobile embedded database, and so we have full support for SQLite, so you could take that data and insert it locally in SQLite to have offline data. You can also use SQL CE on Windows Phone, and so if you've used that in the past, going back the last 10 years that's been around, you can certainly use that. But I'm going to show you a third way to do it. Sometimes you're not downloading thousands or millions of rows of data. Sometimes you have smaller sets. And I'm going to show you a way to do it where you don't have to do all that stuff. So right here, I've created a couple of methods, a save collection, because what did we return? We have a collection of objects, a generic list of products or customers. And the cool thing with that is those are in memory. And then we have our link, language integrated query. You can query that collection of objects using SQL-like syntax in your app. And so if your data requirements are not as huge that would require a real database, you can actually do what I'm going to show you here. And so you can query the collection of products like I just showed you in the IntelliSense. And then I'm going to step through. I'm going to hit F11 and go into this. So I've just really simple. And you're going to get all this code. And you'll see this code's identical on both platforms. So I've got this simple little function here. It's an asynchronous one called save collection. You could call it save table because that's basically what it is. It's our database table, and it's going to save it offline. So on a table by table basis coming from the server, you're going to be able to serialize these and save them locally on your device in a JSON format. And so just stepping through this, basically I'm testing to make sure it's there. And then if it is, I'm going to create the file for it in my local storage area, either on my phone or on my tablet or laptop. And then there's our familiar JSON data contract serializer there. We're going to use that, and then I'm just going to write that out to the device. And basically that just writes the stream out there. And so you can just use this over and over again for any kind of collection that you have. And then I need to prove to you that I actually did it, and so I'm going to pull it back. So now I'm going to have the load collection. And the reality is we could have saved it. I could have stopped the project. I could have shut down the phone emulator, rebooted it, and then the data would have still been there. So it's offline data just like you have to have with mobile applications, just like it would have been in a database. So here's the simple load collection. All I'm doing is passing the name, in this case, products. Remember how we used to have databases in the past, like DBase and Paradox and all the other ones where each table was its own file? Just think of it that way. So in this case, I'm just going to go through and load this collection of objects from my local storage using, again, I'm going to cast it and use this JSON serializer, and I'm going to read from it. And then just to prove to you, before we go back to the main solution, if I highlight the collection that it pulled off the disk, there's our collection of objects. And so these can all be bound, data bound. You can fill lists, whatever you want to do with it, and combine things together. And so we get out of there, and we're done with that. So let's see. So we got the products. So I'm going to quickly go ahead and download customers. I'm not going to debug that because we already understand what happens. So now let's upload an order. So I'm just going to pre-build an order here. And so again, now I'm going to show you how to host things. And so as we walk through this code here, you can see I'm just going to create an order object, just like these other objects you've seen. And I'm just kind of hard coding it in here for the example, order ID, a customer ID, and a product ID that maps back to, products and customer IDs that you saw in those tables. So I'm matching this customer decided to buy this product, and we made this unique ID for this order that we need to purchase. And so I add that to an orders list. And so there's our order that we need to send up. So remember, it's customer ID 2 and order ID 1 and product ID 3. And so now I've got to use my order object that we've created that's been empty to do the casting and create it into JSON. And if I highlight over data here, you kind of get the idea that it's turning into a JSON format. And then it's real simple. I make sure I tell that the header types is application/JSON, and then I'm going to post to that same address that we've been going to orders. And remember, I'm just using URIs. I'm not doing calling a SOAP web service where you see an extension or anything like that. So it's very restful. Now, we instantly are taken to my other copy of Visual Studio, and let's just prove that we actually got the object we were thinking. So we're hitting the post method of the web API, and there it is. Those are the values we're expecting. And now I'm just going to do your typical SQL connection, except now I'm going to do an insert into the database and execute non-query, and if everything works okay, then it'll come back, and we got a response code. Now we're back on the client. It's great how all these Visual Studio copies can just bounce back and forth. And so it worked, and so we're done with that. So now let's quickly go take a look here at the orders table and see if the data is still there. It's already up. It's already sent it up. So let me look at the top. All right, so there's our order. So you saw how quickly that worked. It placed an order into the order shard that's on a node, we're pretending, and then the sync technology built in the replication already grabbed it and pulled it up to the top of the hierarchy. So one last thing we'll do is now we need to, let's do the same thing with the tablet, because we all want to build tablet apps. I won't go into detail of debugging all this, except to let you see that it's the same code. But now we're in a tablet simulator that you get with Visual Studio to building RT and tablet apps. And I'm going to download products. And as you can see here, it is the identical code. And there it goes. It's hitting the server. It's coming to the device. It's successful. So we're on the tablet. There's our products. Works like we expect it to. So let's keep running that. Let's download the customers. Now let's create an order. And again, identical code. Everything's the same. You're reusing everywhere. And I'm going to post this order. And of course, this time I made the order different. The order ID is 2, customers 3, product ID is 4. Now you see it post back onto the server. Those are the right values. And we're going to hit continue to insert those. And let's quickly look at the sharded orders table again really fast to see if we can catch it. Yep. All right, so we caught it out at the shard level. And so you see the order posted out to that node. And then the replication engine is going to pull that off of there and take it up to the top. So let me go ahead and stop debugging these. And so go back to SQL. So let's see if it's gotten rid of it. Okay, so now you see it's now gone. So remember that 1 = 0 filter? Grabbed it and sent it up the chain. So now we're almost done. We go back to the top of our hierarchy. And there's our 2 orders that we placed from our devices in the field. So you can see this is really happening now. We've built a real MEP system. But we're not done yet. We have to get it back to our back-end system, right? So we know the final step actually isn't SQL Server. It's a mainframe. But we'll use Access to pretend we have a mainframe. So what do? We go back to our data tools. And so here it is. You can see in this case it's going the other direction. The mobile middleware SQL Server is the source. And then the destination is that Access database. And so if I just quickly run this, I got 2 green check boxes. If I look down here, I know it's hard to see, it's really small, but it sees that it wrote 2 rows. And then to prove to you that it actually worked, let me refresh this. And there's our order. And so we've made the complete round trip, and it all works. It's always nice when a thing comes together, right? Because there's a whole lot of moving parts on this laptop. So we consumed those REST services, we deserialized it, we saved it offline, we created a new order, we uploaded it, everything was password protected, you use your MDM capabilities to lock down the device and force a PIN, encryption on the device. This is what those devices look like that are consuming that data. And again, I used object serialization, which was a real simple tool, and you might find that it works perfect for a lot of your apps. And then here's the whole thing. So this is what we just did in the last hour here, or a little more than an hour, is we built this. And so this looks like a whole lot to consume, but we did it little by little, did baby steps, and we made it real for you by building the whole thing on my laptop, and we made it from end to end. So we talked about enterprise concepts. We actually built our mobile middleware with SQL 2012 and IIS and used the data tools for ETL. We published it out. We consumed it from 2 different devices. And so hopefully at this point you're equipped with all these building blocks. Obviously you'll have these slides, and then I'm going to make sure I get you this code, this boilerplate stuff, so that you can reuse it. Some of this is already on my blog on robtiffany.com. I've been going piece by piece actually on my blog, building out. So I kind of did first a section just on what MEEP is. Then I've done one on the ETL part of the back end, and I've done one on a blog post on how to scale out SQL Server. So I'm going to make sure I get all the other articles built out for you, and they'll be in much, much more detail actually than even this is, because we only have an hour of time. So now, of course, is the time that we need to see who gets a phone. So has everybody filled in a little slip when you came in? Someone's going to be collecting those. Maybe they're outside, or what are we doing each time? Are you collecting them, or have they already been?
No, I collect.
You get them?
Okay, yeah.
Okay, great.
In a moment you need resolve any answer any question?
Absolutely. Absolutely.
People have questions.
Yes.
At the moment.
Yes, this is a good time for that. Yes.
My sync scenario is a lot more complex.
Sure.
So I send the date, last time sync,
Mm-hmm.
and then I get new data. Because it's lots more than just simple.
If everybody maybe could pass your cards to the middle inside row here, and we can get them faster.
There used to be something like sync framework.
Yes.
Will there be something like it, or is the old framework still useful?
So that's a good question. Let me say this in front of everybody, because that's a good point. There are other ways to get data out to the devices besides what I showed you. So I showed you building REST services to get it out there. But you can use all the principles that I showed you, from the ETL to the SQL Server to the scale out. But if you want to plug in a different method to get data from IIS out to the devices, you absolutely can. And so if you're maybe you're using SQL CE, perhaps on a tablet or a Windows mobile device, and you want to use, we have that same merge replication that I showed you to scale out. We have a capability to do merge replication, or a different kind of sync called RDA that's built into SQL CE, or a third called the sync framework. And so you have 3 different sync options where it tracks changes on both sides and just sends the deltas over the wire. And so you can plug that in for that last part of the section that I showed you. You absolutely can use that if it makes sense for you, and instead of, because what I wanted to show you was a system that would work with any device, because I'm living in the real world with the rest of you, and I know that you need to support other devices. So my solution is for every device, but yes, if you're running a solution where you can use SQL CE, then you can absolutely use another option there. And again, sync framework, merge replication, or remote data access. So ironically, and I'm glad you brought that point up, so my book here actually uses, since it works on the desktop side, even though it's mimicking, if you look at the app here, it looks like a Metro app, but it's actually a desktop app. I show you how to make desktop apps that work with SQL CE and sync to work on the desktop but look like a Metro app for your tablets. All touch-friendly, everything. And so this actually walks you through using some different technologies that you may already have. So, so before we do the device, if you are interested in tablet development, then I will ask a question. You can raise your hand. If you have the right answer, then you get the book. Let me make sure. I need to make sure and sign it. I'll have to find a pen. Anyway, what's the name of the new ASP.NET technology that I'm using to do the web API? Do you know the name of it? Yes, sir. MVC4. Congratulations. You got it. Woohoo. Excellent. All right. But probably more important is getting a phone, and I totally get that. All right. Let's figure out our lucky winner. We have our professional Las Vegas card shuffler here.
Yeah, but now this is street poker, okay?
Oh, we still have some more. All right. All right. There's a lot of cards there. That's good. Okay, our lucky winner is Nareel Mahmood. Congratulations. Excellent. Well done. Thanks for coming. Excellent. All right, well, I appreciate you taking the time to spend time with me this morning. I know we crammed a lot of information in a short period of time. I will be at our booth, the Windows Phone booth, today, most all day. I'm going to do a session at 1700 on HTML5, but I'll be at the booth the rest of the time if you want to come spend some more time asking